Hello, algebra students. Mr. B here, and today we're going to look at the domain of composite functions. All right, our first example is f of x equals 1 over x minus 6, and g of x equals square root of x. If you think about it, f of g of x, the composite function f of g of x, would equal 1 over square root of x minus 6. So what's the domain of that function? I think the best way to figure it out is to analyze the problem using the schematic diagram that these composite functions can be represented by. So x starts and goes into g. We always start from the inside out. The x goes into g, and that spits out g of x, and then that goes into f, and then that outputs f of g of x. Let's see. So what's in these boxes? G is square root of x, and f is 1 over x minus 6. Those are the key pieces you really want, is to put what the function is inside the box. It goes into g first, and then into f. You don't really need to know that that's g of x, and well, I'll leave the f of g of x over on the right. What we're basically looking for are all the numbers x that we can put through the whole thing that goes through both boxes without causing harm to either of the functions, and we get a real number out on the right side. So let's start with g. That's the first thing to do. So it's the square root of x. What does x have to be so that you get a real number? Well, we know that we can't take the square root of negative, so x better be greater than or equal to 0. You can take the square root of 0 and any number bigger than that, and we're good. All right, so that's the first cut now. You can't have x's that are smaller than 0. All right, for f, can you see that if x were 6, that the denominator would be 0? We can't have 6 here. 1 over x minus 6. If x were 6, we'd be dividing by 0, 1 over 0. All right, so what x going into g would spit out a 6? Now this one's so easy you can probably think about it in your head. You go, oh yeah, if we throw in 36, then we take the square root, we get 6, and then that would be a problem for f. So we don't want x to be 36. Another way to figure that out is to actually set g, the square root of x, equal to the value you don't like, and solve this. We know that if we square both sides, we get x equals 6 squared, and that's where the 36 came from. Okay? All right, so the conditions for the domain are x has to be greater than or equal to 0 and not be 36. So the domain of f of g of x is, and we write this in interval notation, bigger than or equal to 0. That means we've got to start with a bracket at 0, a square bracket, and it would go to infinity except we want to throw out 36. So we're going to go up to 36 with a round parentheses and union that with 36 to infinity. All right, that is the domain of the composite function. Pretty easy to figure out. Okay, next one. One more here. So now our f of x is 1 over x minus 4. G of x is 1 over x plus 2. If you want to see what the composite function would look like, f of g of x, it looks like this. All right, so let's create the boxes here. And we know that it goes into g first, and then it goes into f. And let's see, g was 1 over x plus 2, and f is 1 over x minus 4. Okay, we start with the left one again, which is g. What don't we want to happen here? We can't have division by 0, so if x were, just looking at it, negative 2, right? X cannot be negative 2. I mean, you can solve for this. You could say, oh, x plus 2 equals 0 and solve for that, and you get x equal -2. That would make it 0. That's where I got this. Okay, so x can't be -2. We can't throw a -2 in from the left side into g or we have problems. Every other number is fine. Okay, now, what can't we throw into f? I see that's 1 over x minus 4. And I hope you can see immediately that the problem would be 4. We can't throw 4 in here or we cause problems for f. But what creates a 4? What number x, when it goes through g, creates 4? So that's our real problem right now. So set g, 1 over x plus 2, equal to 4. And we'll solve this. We'll see what x has to be for that to happen. It's pretty easy. This is a rational equation. We multiply both sides by the LCD, which is x plus 2. And that'll cancel that, leaving 1 on the left. And then if we distribute the right side, we'll get 4x plus 8. And we could take away 8 from both sides. And then we'll have 4x equals -7. And then divide by 4. And it looks like if x were -7/4, right here, -7/4, the output would be a 4. You could test this. You could go, okay, 1 over -7/4 plus 2. You know, what is that? That's 1 over -7/4. 2 is 8/4. And that's 1 over 1/4, and that happens to equal 4, which is the problem. Okay, so -7/4, x cannot be -7/4. So these are the two conditions on the domain. And now we can write it down. The domain of f of g of x is the set of real numbers, so -infinity, and then we have to basically block out the two numbers we didn't like. So what's more negative? I think -2 is more negative than -7/4, right? So -infinity up to -2, unioned with -2 up to -7/4, and then union -7/4 up to infinity. And so this set, I know it's 3 pieces we're gluing together with unions, basically has holes at -2 and -7/4 because we're using parentheses. Those numbers are not included. But every other real number is good. All right, folks, we'll see you at the next video.